Hello, welcome back to our little corner on the web. Today, we will be discussing question 14 in part 1, the 26th PMO area stage. Again, thank you to the organizers for freely sharing the questions. Question 14 states that for a set T of numbers, we define S of T to be the sum of the elements of T. We take the null set having the sum of 0. As usual, the cardinality of T denotes the number of elements of T of a set T. Let A be the set of positive integers less than 1,000 whose digits consist of only ones and threes, or both. We choose a random subset B of A. The probability that set B and the cardinality of B end in the same digit can be expressed in the form of A over B, where A and B are relatively prime positive integers. What is A plus B? Okay, for this one, we'll hopefully just use a pen. Okay, so first we try to just make a quick list of the positive integers less than 1,000 whose digits end in, or whose digits only consist of ones and threes, right? So basically, if it only consists of ones and threes, we can separate it into two sets, ones that ends in 1 and ones that ends in 3. So we have 1, 11, 31, 111, 131, 311, and 331. So those are all the ones that ends in 1. And the ones that end in 3 are 3, 13, 33, 113, 133, 313, and 333. Okay, so there's 7 of each. Okay, so here we want the last digit of the sum to be the same as the cardinality or the number of elements in that set. What we first notice is, let's look at the elements that end in 1. If we pick one of those elements, we add to the sum of 1 in the units digit and change the cardinality or the count within that set also by 1. So if we take S of some set C minus the count of C, if we pick from the set that ends in 1, it doesn't actually affect the units digit of the difference. Okay, so no effect. Okay, basically, if it's already equal, then it will remain equal. If it's not equal, then the units digit of both the sum and the cardinality both increment by 1, right? Yes, there's a corner case that 0, a 9 goes to 1, a 9 goes to 0, but the effect is that mod 10, it's still the same. Okay, so what this means actually is if we already have a subset where the units digit or of the cardinality and the sum is already equal, then adding any of the elements that ends in 1 has no effect, so no change. So we can either now choose to add or not any of those 7 items. For the ones that ends in 3, okay, for the ones that ends in 3, what we find is there's a +2 net effect. What does that mean? Oops, I can't spell. There's a +2 net effect. Okay, because what happens is the sum, the unit digit of the sum will have a +3, but the count will only have a +1. Right? So technically, we will need 5 elements that end in 3 to make the units digit go back to equal if they started as equal. Okay, or we could also have no elements that ends in 3. Okay, because our base case, if we're just starting, the sum and the cardinality both end in 0. Okay, so there's really only 2 cases for the 3s, right? Okay, so let me try to, oops, let's not delete all of it. Okay, so either we have a case where we have no threes, right? We have no threes or 5 threes, right? And we can intermix this with any number of elements that ends in 1. So that means there's 2 to the 7 ways of choosing the ones. And the two cases we can write as 7 choose 0, okay, where we have no threes, plus the case where we have 5 threes. So that's 7 choose 5, okay? All over the total number of cases, which just means either one of these elements is in our subset or not. So there's 2 to the 14 of those cases, okay? So simplifying this a bit, we basically have 7 choose 0 is just 1, plus 7 times 6 over 2, all over 2 to the 7. This is just 7 times 6 is 42, 42 divided by 2, 21, so that's 22 over 2 to the 7 is 128. So that simplifies to 11 over 64. Okay, so the final answer is really 64 plus 11, which is equal to 75. Okay. Again, this is just one way of solving it. We hope that you found this useful and educational. If you did, do hit the like and subscribe. Thank you for watching.